Hello everyone, I hope you're all having a good day. I am Ben Jammin from Jammin Studios, and I am back with another video. And today we're going to be creating another enemy. This enemy is not going to be like the turret. It's actually going to move around on these platforms. It's going to move back and forth, and when it reaches the edge, it may fall off if we choose so, but it could also, as soon as it reaches the edge, go back where it came from and just keep going back and forth on that platform. And that's what we're going to do today. We're going to first actually start off with a couple folders here. We're just going to make some Node2Ds. This is going to be the, I thought I had it. This is just going to be the enemies node. We're going to stick that turret in there. Then we're going to make another child node. Another Node2D, called this one the turret node. Stick the turret in there. Then we're going to get one more. We're going to call this the guard node. So now we'll have a whole bunch of enemies throughout the scenes, and that if we didn't have these, we would have turrets going all the way down, guards going all the way down, making this whole scene tree right here extremely long. But since we have these nodes, all we can do is just hit that little button right there, and it's all in just one node where we cannot see the children of it. And that's why we honestly want to do this. We can do it for the coins as well, because those are going to be a big amount. So we're going to do that right now. So Node2D, we're going to call it coin node. And if we click the top, the coin one, hold shift and then click coin 3, we can actually select all of it and move it down to the coin node. And now it is a child of it. But today we're going to be working on another enemy. So we're going to come over here. This one will be moving around, so we're going to want a kinematic body 2D, and we're going to name him guard. Now our guard is going to need a sprite, and the sprite I already have loaded in. Where are you? Here you are. I think I have to import it. Yeah, I did not import it, so we'll do that. And now we have our little guard here, and we're going to just not offset. We're at animation. We're going to go to animation. We have 3 vertical frames and 4 horizontal frames. There we go. Now we have our little character here. And last but not least, we want our collision shape on this guy. And we're gonna go with a capsule for now. We're gonna shrink this down as well, so it's not his entire body. We want to get a good amount of it. I do want just a little less than what he actually is. That looks about good. I don't want to take up the entire body. I don't want to engulf the entire body, because this guy will actually do damage to us. So that's why I'm wanting to get just under his body, so it's not very annoying that there's a hitbox outside of the guy and people are freaking out about it. So that's why I want to get one a little closer, a little more in. And then, of course, we're going to need an animation player, because we don't want our guy to just stand there and look awkward as he moves. And let's save this scene to enemy guard. There we go. Now, we're going to go to our enemies and instance him in our guard node. So let's instance the guard in there. And, that's not what I want to do. Trying to grab. Alright, how can I do this? Go 10. There we go. Now we pulled him out of that group there, and we can move him around. So we're gonna have the guy be right here, the guard. We're gonna save the scene, and we're gonna play it. But you can see that he is just standing there doing absolutely nothing. We can interact with him. as all kinematic bodies can do. But we actually want him to do something. So what we're going to do is we're going to add a script to him. Guard script, yes. And we need to add gravity. So we're going to go var velocity equals vector 2.0. If you remember this, we made it on our player script. This is pretty much the exact same as that. So we go with a 10. Velocity is going to be a 0, 0, and gravity is going to be 10. Then we're going to go with our function, our physics function, physics process delta, and go velocity dot y plus equals gravity, because the positive y direction is going down, and then our velocity equals move and slide velocity. And if we save that, oh, what is this? Oh yeah, it's fine. It's saying we're not using delta, but that's okay. Actually, we're not going to be using delta at all today, so we can just do that. This will eliminate the little error that pops up here. It's not anything major. It just says like, hey, this isn't being used. If it's not being used, then just put an underscore here so we know that it's not going to be used, and we won't do anything about it. And now look, our guy is now on the ground. So that is fantastic. But we want him to actually move around. So he's going to go back and forth, left and right, and we want to make sure we know which direction he's going in. So we're going to go with var direction here. And since he's facing to the right, he's facing to the positive x direction. So we're going to go with 1. Now this will become more clear why we went with 1 in the future, because we're going to make our ready function here. And we're going to say if the direction is equal to -1, then we want to flip the sprite around. So sprite flip h equals true. And this will basically tell us if he's facing left or right. Right now the direction is 1. We should actually export this. We should export that. And this will allow us, as if we hit the guard, see now here, this will allow us to change the direction. We should only change it from -1 to 1. That's it. Because the direction is basically which way he's facing, because we're going to be multiplying the direction by our speed, just by our speed. Also, okay, yeah. We're on the right path. All right. Then our next step is to make him start to walk. So we're going to go with velocity.x equals to speed times direction. Now we need to get our speed going, so var speed equals 50, but we're going to actually export this value as well. Alright, so now he should be moving, and he fell. But that's okay, because we're going to be messing with something we haven't messed before, which is a RayCast. These things are very nice and can detect a lot of things. Now, it does disable at the start, so you have to go over to the right and enable it. And we don't want to cast it too far. We want to cast it, what about 10? No, actually, hold on. I think 10 would be nice because that's 8. Yeah, so let's just go solid 12. Let's go solid 12 there. Yeah, I think 12 is like right there. So we'll go a solid 12. This we're going to rename to floor checker because that's exactly what it's going to do. We're going to come back here to our script, and in our ready function, we're going to go with floor checker dot position dot x equals collision shape 2D dot shape. Now we have our oval. We have our oval here, and if we click the shape, we have a radius, height, and a custom solver bias. Our radius is 5, so we want the shape dot radius times the direction. So we get the shape's radius, which would be 5 in that case, and we multiply it by the direction, by what we have, which is basically a 1 or negative 1. If it's 1, it's going to be at 0, 5, or 5, 0. If it's negative 1, it's going to be at negative 5, 0 on the left side of it. And that's what we're going to want there. And then, okay. And then we're going to make another line here. So the floor checker dot enabled equals detects cliffs. Now we're gonna export another variable here. Hold up, I might have to sneeze. Now this one, this one is where we decide. Actually, do we want the guard to see if there's a floor or not? That's what the detect cliffs actually is looking for. That's if we disable it, then they're just going to fall off, and if we enable it, they're just going to go back and forth. And that is all for the ready function. Now the process delta, this is where things get just a little bit interesting, because we're going to create a function here that will actually tell the guard to go back and forth. So if is on wall, this will come back true if we run into a wall. This has nothing to do with the floor checker at all. Or not floor checker dot is colliding, and detect cliffs and is on floor. So what the next three things are basically saying, I think I spelled colliding wrong. So not floor checker is colliding. So the entire time it's enabled, our RayCast is colliding with our floor. That is what we want. We want that to be colliding with the floor. But as soon as it's not colliding, this will return true. So as soon as there's an air pocket, it will come back as true. Then we have our detect cliffs. That is true. So we want to detect if we are, this will say like, okay, we want it to detect cliffs, so it will come back true. If we don't want it to detect cliffs, it will come back as false. And then lastly, if we are on the floor, then it's okay, because if we were just in the air falling, they would just constantly be flipping back and forth, because the whole right side is true, and it's an or, so that's all right. And if we actually have cliffs, detect cliffs as false, and they hit a wall, they will still come back the other direction. So now we actually have to fill this in. So direction is gonna equal direction times -1. And this will flip everything else now that we have to add everything else to actually make it flip. So then sprite flip h equals not sprite flip h. So this will make it the opposite of whatever the sprite dot flip h value was. And then last but not least, we must get the floor checker dot position value here dot x equal to the collision shape.2d shape dot radius times the direction, which is basically the same thing in our ready function. So if we play this, he is freaking out a lot. I just realized why our character is freaking out is because our velocity.y value is continuously increasing. We need to tell the script of our guard to not increase it. So we need to tell it what direction we need to go in, which is vector2.up. And this will tell it to stop adding gravity to our character if we are on the floor. Yep, and there you go. Now he's going to go back in between us, and we're technically a wall in this case. So he's going to just keep colliding with us, bouncing back and forth. We can push him right off the edge, look at that. But that is basically our character right there, our little guard. You know what? Can I? No. Ooh, we actually kind of rode him. Ah! Look at that. That's our guard right there. In future episodes, we'll actually be able to take damage from him, and if he goes off the screen, we'll stop his script so it doesn't keep on running. And we'll be able to hit him on his head whenever we jump on him. So we'll jump on him, hit the head, and there we go. We're on top. But back to what I was saying, if we jump on his head, we'll basically smash him and kill him so that we can move on with our progress in our game. So thank you for sticking around to the end of the video. If you like it, please like it down below. If you support with the content that I do, subscribe to my channel. And if you have any questions about GODOT programming, then don't be afraid to leave it down in the comments. Thank you. Enjoy.